This was a big week. You may not have realized it at the time, but this week you were introduced to one of the most important concepts in all of physics, and it was not just gravity. We talked about universal gravitation. Here's the Earth, here's the moon. We know we have a gravitational force of the Earth on the moon. Oh, and by the way, we actually have the same force of the moon on the Earth. The Earth is so much bigger that we usually don't worry about that part. And that's the reason the moon goes around in circles and causes the tides and all that. And we have the equation GMM over r squared. And you can think about orbits. None of that is the most important aspect in all of physics. Okay? The one thing we talked about that was so big was the concept of a field. We talked about how it's not just that the Earth pulls on the moon because it sees that the moon is there. The Earth changes space, does something to the space around it through the whole universe, such that any other object feels that change in space, and that's why this force happens. The field is a way to describe action at a distance. And the reason that's so important is you'll see more and more fields if you keep studying physics. So this equation, F equals G m12 over r12 squared, is how you describe the force for gravity. But later, if you study two charges, here's a charge, say plus q, and here's a charge minus q. Getting ahead of ourselves here, but if you have two charges in space, they feel an attractive force, and you describe that with an equation that actually looks quite similar. Coulomb's constant, the charge of one, the charge of the other, over their separation squared. Okay. Again, we're using the field concept. And if you keep studying physics, then you're going to find if we have the charges moving, minus q maybe moving this way, they're going to feel a magnetic force between them. Moving charges feel a magnetic force. The magnetic force is not that simple. It's more complicated than that. And if you keep studying physics, you're going to find that the electric force and the magnetic force, and you throw in a little relativity, are actually the same thing. It's the electromagnetic interaction. So a lot of classical physics basically just boils down to gravitational fields creating forces on each other and electromagnetic fields creating forces on each other. All the other forces, at some level, are a product of these that we talk about. Tension and friction and drag and all those. Those are sort of electromagnetic, and then you got to throw in the whole molecular structure, quantum mechanics, et cetera, et cetera. You know, when you go to the microscopic scale to figure them out, suddenly it's atoms, and you have to think about orbits and everything. But ultimately, a lot of that is those interactions are due to electromagnetic interactions. Then you go in the nucleus, and there's other fields to think about. But basically, the field concept is the basis for all of physics, and so this is the first time you saw it. So get used to this idea. There's this field that explains how things interact. It's very fundamentally very important.